Good morning, everyone. Welcome to day 2 of React.js Conf. I hope that you had a great day 1, and today is going to be even better. So, my name is Christopher Chedeau, and I'm also known as Visual on the internet. And I'm actually not a conference organizer. My day job is being an engineer. And it's been like some crazy the last 3 months has been like crazy. But now I'm going to talk to you about React Native. So the reason why we build it is we want to get the best part out of native, and we want to get the best part out of web. So when we did the transition from web to mobile and to native, like we won a lot of things. Like the user experience was better, the performance was better, but we also lost things at the same time. Like the developer experience was worse. Like we have to use imperative, mutative APIs again, like the DOM. The compile time and linking time and build time, like all of those, they add up. And we really want those from the web. So in this talk, I'm going to tell you what makes an app native and feel native, sorry. And I'm going to tell you how we did it in React Native. So there are really three big pillars in React Native. The first one is touch handling. This is, I think, in my mind, the biggest thing that's different from like mobile web. iOS and Android touch handling is much better. But we don't have that much time, so I'm not going to go too deep into those. The second one is native components. So it turns out that there's a lot of really high quality native components that already exist. And people just try to re-implement them, but they never feel as good as native. So we really want to be able to use those instead of trying to reinvent the wheel. And the third one is style and layout. And the reason it's so important is because layout impacts so much the way you write code, and it's vastly different from the web, from iOS, and from Android. And so we want React Native to be learn once, write anywhere. And so we also want to be learn once for the style and the layout. So let's get started with native components. Can we switch to my computer? Very cool. So yesterday, Keynote showed you this movies app demo. And the interesting thing about this is everything that you see on screen is native. But when you look at how it's implemented, this is the main file. And as you can see, this is just JavaScript. This is a React component. So the entire app is a React component. And there is no Objective-C here. But this component is actually a native one. So let's dig a bit more inside of the file. And as you can see, like if you've ever written any React code, like this should feel like super familiar. But there are still some differences. For example, you've probably never used this text component, nor this view. But if I tell you that they are the equivalent of a span and a div, then you should like be ready like in a few seconds. So how is this view component implemented? Well, let's open up Xcode and look at RKView, which is a native one. And as you can see, it extends from UIView. So this is actually a real native component that we're instantiating. And so now if you look at RKUIView Manager, oops, not this one. RKUIView Manager, sorry. And so how is it working? So the way we do it is this is a declarative API using React. And then we're taking this, and we're going to look at all the attributes that we can have, and we're going to extract them, and we're going to set them to iOS view, the mutative one. So this is the same way we implement divs and span in React. But instead of having to output DOM commands, we just output iOS native commands. And what's interesting is this view operation, this is done on the main thread. So this is the only thing about React native that's done on the main thread. This is just setting the views. So React, all the layout, everything is done in a different thread. And at the end of the diff algorithm and all the React logic, it's now flushed to the main thread. So this is interesting. And so now you may wonder, like, how is it running? Are we using JavaScript and transpiling it to Objective-C or C? No, we're not doing that. So what we're doing is we're actually running the real JavaScript, a real JavaScript engine. So in this case, what we're doing is we're running JS Core, which is the JS engine in iOS. But let's try something. So we're going to debug reload in Chrome. And no, I don't want a new Safari, and Chrome exited. OK. And OK, this crashed. So yeah, and this time is everything that it's all this time that you have to wait for every single change, like using a normal native app, which is quite a long time. So let's try this again. Let me open Chrome. So if I debug reload Chrome, so what is happening here? So we are running the JavaScript, the React app for this. We are running it inside of Chrome. So Chrome is actually running the JavaScript. So we're using like V8 on all of those things. And as you can see, we can have all the React tools, like the console and everything. And I have no idea what the console is. Yeah. And what we're doing is we have a WebSocket connection between the iOS simulator and Chrome. But this is like inside to get like better developer tools. But we could imagine, and it's already working, like getting your iPhone like connected via Wi-Fi to like your laptop and running the JavaScript that powers the app like remotely. And one thing that we can get as well is why not run it on the server for low-end devices? So those are like some crazy ideas that are actually possible. So we don't know if it's like useful or not, but at least like the same way like Ryan Freund said, like we don't like to say no to people, and this allows us to say yes if this use case comes. And one thing that would be cool is, what if we could server-side render native apps? Maybe, like, we could do it. So let's reload again. And so, yeah, like this is just a like simple app. And have you looked at the time it takes to reload? Imagine like the Facebook app, like it takes like multiple dozens of seconds in order to like do any small change. And we really want to fix this. So let's go back to the slides. OK. So this is how we are using native components. And then the next thing is you may wonder, like, OK, we can render native components, but how do you style them? And so if you're coming from the web, your idea is you're going to say, like, oh, we're going to use CSS. But unfortunately, CSS has some issues. And we've been using CSS at Facebook for a long time, and we've had to do a lot of workarounds around it. And it turns out that we believe that there's a better solution. And this is CSS, or writing CSS in JavaScript. And I did this talk 2 months ago at Nation.js, and this was the reaction on Twitter. But we're now starting to get used to it. This was the exact same reaction that we got when we open source React. And people complain that, oh, now you're collocating your markup with your logic in JS. And for the same reason that they turned out to be a good idea, we believe that collocating your style with your JS is a good idea. So those are all the issues with CSS. And at first, I was like, I didn't know if writing styles in JS was going to work, but when using it, it turns out that all of those, like every one of those, were solved without hacks. So how is it working? This is how you declare your styles. And if you've ever written any JavaScript, like this should be like super familiar. Like you shouldn't be lost from CSS. So there are a couple of differences, like you have to put commas instead of semicolons, but like nothing like really big. But what most people trip on is how do you use the styles? And this is it. You're using inline styles. So it's been 10 years. And all the best practices were do not use inline styles. So what changed? Well, I would phrase it otherwise. What's the difference? This is how you write styles right now on React. And so if you look at the two, like they're pretty similar. So the first thing you'll notice is we're not using class name anymore. Yes, no big debates about this anymore. We can just use style. And the next thing, which is like a lot more fundamental, is look at movie year. This is a string. And why would we want to do a string? Like this string, it has to be a reference to something in like the CSS, and it's a global, and like this is there because we were separating technologies, JavaScript and CSS. But what we should do is to separate concerns. And so we still have this separation of concern with this, because the actual styles are separated from this call, but we can use all the power of JavaScript. This is just a JavaScript object. You don't need to, you can use like all the functions to generate those. You can use variables. We just got them in CSS. Like you can export, like you can have a module that shares all your like variables and everything. So we believe that this is a much better thing. But this is only one part of CSS that we ditched. CSS is actually much more than that, and like I would say it's not modular for all what that means. So CSS also has a big property, which is layout. So the first thing is, what is layout? Well, if you take this screenshot, and if you put yourself into the GPU shoes, everything it sees is boxes full of pixels. And the goal of the layout algorithm is to build those boxes. And its only goal is to compute 4 values: the top, the left, the width, and a height. And that's it. But it turns out there's a lot of ways to do it. So we first looked at how iOS does it, because we want to be native. And the first thing is you can implement a method called size that fits. And what it requires you to do is to write code that computes those 4 attributes: top, left, width, and height, for every single element that you see on screen. And so, like iOS developers, they have to write pages and pages and pages of like just boilerplate code to like display simple things. So the next thing that iOS has is auto layout. And auto layout is using a constraint solver, and they sold it in a shiny box. But if you think about it, what auto layout is a constraint solver. So you've got to define linear inequations, and you still have to set the top, left, width, and height inequations on all of the elements that are on screen. So if you're building applications using code and not using a GUI, then you don't cut that much on the boilerplate. But unfortunately, linear constraint solver cannot express everything that you want. For example, it cannot express line breaks. So you cannot have multi-line text encoded in a linear constraint solver. And so there are ways to work around this, but all of those ways, they lose the mathematical properties that it's going to give you the absolute best layout, which is why you use the constraint solver in the first place. So we didn't find anything that we really liked on iOS, and then we turned on the web. So the first thing on the web is the CSS box model, and this is the best way to do layout I found. Just those three simple attributes, margin, padding, and border, and you can express the layout for every single element you want very easily. But then, if you want to lay out multiple elements, this is insanity. Have you tried to vertically center something with CSS? Or to do a multi-column layout? I've tried. And with floats and tables and all of those acts, but it's really hard. But it turns out that there's a better way, which is Flexbox. So if you have never used Flexbox, you should try it. This is that good. So let's take an example. We've got this, and as you can see, there are two columns, and the text is vertically centered. So I would challenge you tonight to try to implement this using CSS, and let me know how it goes. But with Flexbox, it's actually super simple. You just do align item centers to vertically center them, and flex direction row to lay out things in multiple columns. And so, I'm a big fan of Flexbox, but if you think about it, React Native is a JavaScript engine, and it's all the native components. And nowhere in there is Flexbox. Because when you're on the web, Flexbox is implemented inside of the browser. And we don't have a browser. We don't have a web view. So how do we re-implement this? Well, we are all developers. So we fire up Jasmine, and we start writing some tests. And so what the layout engine does is it takes a tree of styles, and it outputs a tree with the same shape, but where all the values are just 4 numbers: width, height, top, and left. And so I started writing some tests like this and to implement margin, padding, all the Flexbox attributes. But at some point, I didn't know if what I was implemented was correct. And so because we're in the browser, in this particular example, we can just take this tree as input and create actually real DOM elements and put some styles. And we can send them to the browser and ask for the browser to compute for us the top, left, width, and height. And so I did this for a while, but then at some point, I couldn't find examples where my algorithm was failing. So I started generating a bunch of random tests. And the great thing with this is I can just generate a lot of random tests, send them to my implementation, send them to the browser, and see if it passes or fails. And so the workflow was the following. I would run the random test. I would find the first one that fails. I would fix it, and I would iterate. Find the first one that fails, fix it, iterate. And at some point, there would be no failing test. And so at this point, I was confident that the implementation was right for all the attributes I supported. And then I add a new attribute, and I do it again. And so using this extreme TDD style of development, I was able to re-implement Flexbox, all the attributes that we wanted, in about 2 weeks, which is crazy. And so I want to emphasize on the fact that we only re-implement a subset of CSS. And the reason why is CSS has a lot of things in it, and a lot of legacy things that we may or may not want to support. And so we focused on only the things that we know are useful for developers, and only the things that we know we can implement fast. And so at this point, we had Flexbox implemented that was working right on the browser, but, well, this is React Native. We want to use it on iOS. So how do you do that? So the first idea that comes to mind is we are going to take Flexbox. So we're going to take this JavaScript implementation, and we're going to bridge it, and we're going to execute it like real time in JavaScript. But for doing layout, you need to measure text. And all the text measurement APIs are in Objective-C. And we've got one very important property of the bridge between JS and Objective-C, which is that it's asynchronous. So we couldn't just run it like this, because we would have to re-implement it in an asynchronous way, but it doesn't work that well. So what we decided instead was to port this Flexbox implementation from JavaScript to C. And actually, we also ported it to Java. And so now we've got the same layout implementation that we know that we want running on all the three platforms. And because it's probably useful to have an implementation like this, without any dependencies on the browser, we also open sourced it a few months ago. So if you need to use it, feel free to grab it out. So can I get to my computer? OK, so now let's code. OK, so how is it working in practice? So this is the Movies app. And we got a request from the designer that says, oh, I don't like the image to be on the left. I want it to be at the top. So one thing we can see is, oh, this is actually using inline styles. So this is good. And this style is written, in JavaScript in the same file. Well, that's good. And whoa, it's also using Flexbox. So if you're a JavaScript developer, you should be at ease. So what we want is, instead of rows, we want it to be them in column. And so when I'm going to hit save, it's going to instantly reload, because we have a file watcher that's listening. And so this is the promise of React Native. We want less than 1 second delay between modifying a line of code and showing it on screen. And if you compare this to the Xcode rebuilding that I showed you earlier, it was 30 seconds for this small project, which is insane. But let's continue. So we want to do some modification, oh, this one is not centered, so let's center it. This one is not centered as well. And let's put some border radius. OK. So everything's good. Now the designer is happy, but now the product manager comes. And there's apparently, on the database, a score, a critic score that he wants to show. So, well, let's show it. So we want to show it next to here. So we're going to do this. We're going to put the score in a percentage. And now it displays, but it would be nice if there were some colors. So we're going to do var color equals to RGB. Let's put it red for now. Oops. And one thing I can notice is, we're actually using template literals, all the ASICs goodness. And we want to set this. Again, using inline styles. It's good. And, well, now they're all red. But another ES6 feature, which is pretty cool. You can do that. OK, so now when the score is 0, we want it to be 0 green. And when the score is 265, we want it to be fully red. Fully green, sorry. So we're going to normalize it by 100 and multiply it by 255. And whoa, what just happened? OK, so as you can see, React, as you know, like React, we've tried to do warnings like as best as possible. And this is what we're doing for React Native. If you've got an exception, we're not going to hide it like in your console or everything. We're going to show it in your face. And internally, we like to call it like the red screen of death. So all the arguments integer, this is a float, so we should round it. And this. And so now it's good. So we should do the opposite for this one, and everything's good. So this is the end of the demo. Can you go back to the slides? OK, cool. So what we really want with React Native is that if you're familiar with JavaScript and React, you should be able to get started like very easily. And you should get like the same developer experience at the web. And what you don't see here is that all the JavaScript that we run is using ES6. It's compatible with non-modules. So if you want to use underscore or parse SDK or whatever, just have to do npm install. And if it doesn't have a dependency on the browser, then it's going to work. But we're also able to get like all the benefits from native. And so at the end of today, at 6 p.m., we are going to be given access to a private GitHub repo that contains React Native. So word of warning, what you're going to get is just the bare minimum to run this demo app. Because actually, like 3 weeks ago, we didn't know we were going to talk about React Native here. We didn't know we were going to open source. So like we crunched like for the past 3 weeks to get it in a like ready state. But in the next few weeks, we're going to add a lot more things. And actually, that's it. Cool. We have a few minutes for questions, if there are any. Got the mic? No questions? Go ahead, fast, please.
I'm just wondering what you guys have got in mind for the process for creating projects. So
yeah.
Obviously not today, but in a few weeks when you do open and source it,
yeah.
What sort of build tools do we have to work with? Is it Webpack? How do we get started? That sort of thing. Yeah.
So the way you get started is we have a sample Xcode project that you can just copy and paste, and like everything should be set up in the repo. And then for the actually all the build tools, we're using something that we're working on internally, and not Webpack, but we're looking into it as well.
How do you integrate with platform-specific APIs like Apple Pay or other things that you do?
So the way the bridge is working is you can expose just a JavaScript function. And you, in the bridge, like in this case, I showed an example of component, but you can expose like any function that you want. So for example, Apple Pay, like there should be a function like pay or something. And so you expose it from JavaScript and they can use it. The only constraint is that the bridge is asynchronous. So for example, if you have local storage, which is a synchronous API, then you're going to be in trouble.
How sane is it to do this for desktop apps?
So right now we are like 100% focused on iOS and Android, but we are trying to think like bigger, but like it's a matter of resources. So we are working on the infrastructure, and maybe like 1 year down the road, or if you're interested in helping like spinning up like Windows or a desktop or whatever. But like here, there's nothing that's really like iOS specific. Like you can bridge, if you can bridge components and native API, you should be able to do it. Cool. Well, thank you very much, and I hope you have a good day.